Hi Shiraz, can we look at how the gene box will help us with improving sports performance where power is required, or aka explosive energy?
Yeah, there are many genes which are responsible for sprinting or power production or in the sports where the short burst of energy is required. Now the genes like ACE, then ACT are majorly responsible for producing that explosive power. But these are also genes which are also favorable if they if a person is looking at even a short time trial kind of a sport. So for example, it can favor uh, weightlifter, sprinter, 50 meter, 100 meter, but the hybrid genes in this can also favor time trial person. That means, what do I mean? Time trial is person who's participating in 1500-meter race, 5k or a 10k time trial. Either it's running or cycling, both will be on a high intensity. That means working beyond the threshold levels. So these genes, basically ACE and ACT, they work by a function which is called vasoconstriction, which is opposite to vasodilation. So it constricts the blood vessel and supplies the blood to the working tissue to produce the power. And hence you will see that short burst of energy that can be sustained for a smaller duration.
Okay, so if you take the hybrid gene,
Yes.
and for example, if an endurance cyclist is there, what happens when he approaches the hill? What will be the difference between him and somebody who doesn't have those power genes?
Yeah. So in this scenario, as I mentioned, that time trial can be of 5k, 10k, or even a 16k will be a time trial for the cyclist. Now time trial route is a flat route, but what happens when he is doing a long distance endurance, and he definitely would want to use power, or a force production is required either during the starting of the event or while climbing up hills, especially in relation to the cyclist. So person who's having a hybrid genes will have the equal proportion of slow twitch as well as fast twitch muscle fiber. That means he can use that fast twitch muscle fiber much later or in the beginning of the event, and but for a shorter period of time he may be able to sustain that sprint sprint values, maybe up to 250 meter to 500 meter, nothing beyond that.
So basically, it would help. So basically, somebody who doesn't have endurance genes won't be able to go sprinting on a mountain or on a slope which is upwards, right?
Yes.
So, what other examples can we use for people who have the favorable genotype? Say somebody who has the good genes for power and sports performance. What kind of sports they should play? What kind of athletic ability would they have?
Yeah.
And how can you further develop it?
Yeah. So when we talk about the power genes, then there are other genes also like NOS2. Okay. Then there is actin 3. So it's very important that all these, in all four genes, it favors the athlete to give the excellent sports performance in the power or the sprint sports. And all those genes have a different working mechanism. Like for example, an endurance runner would use more of fatty acid oxidation, but here when we talk about power, it needs glycolysis. That means efficient use of ATP and the glycogen, and it saves fatty acid oxidation for much later use. So person who is entering into a sport which is mid distance, where you will require endurance as well as sports, so having this all favorable genes works to his advantage. That means a power athlete also can be a good athlete in the mid distance sports.
Okay. So how does a power somebody who has favorable power genes, his muscle structure would vary to somebody who has endurance genes?
Okay. So for example, a power athlete, definitely if you see with some of the sprinters, they look more bulky because the type of muscle tissue that they have is red muscle tissue, which is more of a glycolytic fiber. Okay. And mid endurance athlete will not look very lean. He will have some bulk muscles, but definitely much more lesser in density than the those when we compare to sprinters. Now what is the major difference is the capillary density. Capillary is which will supply to the blood to the working tissue. People who are into sprinting, they will have a larger capillary density for the glycolysis for type 2 muscle fiber. Endurance athlete don't need that actually. What does endurance athlete will need is efficient VO2 max, so that more oxygen is supplied to the working muscle, and efficient way the body can use the fats to produce energy for the long distance training or long distance sports. So this is the difference between the endurance and the power athlete.
So what are the different types of muscle fibers apart? I mean, this is red and white, but there's a classification in it?
Yeah, there is a bifurcation. There is only slow twitch, which is type 1 muscle fiber, which is white muscle tissue. There is type 2, which is glycolytic fiber, which is red muscle fiber. In type 2, there are subtypes. There is type 2A, type 2B, type 2C, type 2AB, type 2AC. 5 subtypes in type 2.
And which are responsible for the most, for producing the most power in a way?
Type 2A is the only muscle fiber which is responsible to produce explosive energy or power.
And say if somebody has a NOS gene as well, how can they transition between being a power guy and being an endurance guy?
Yeah. So basically what happens is the NOS genes, it enhances your nitric oxide production. Okay. Now once the nitric oxide levels are increased, normally it will definitely help in a short burst sprinting. But as nitric oxide conversion from angiotensin 1 to 2, it also creates vasoconstriction. So definitely, largely a power as well as the endurance athlete can benefit when it undergoes a vasodilation process. So they make an efficient use of oxygen as well as fatty acid metabolization basically.
Okay. And moving on to, how does muscle building get affected by your genetics?
Yeah. So for example, person who has majorly power genes, so for him building dense muscle fiber or a glycolytic tissue which produces hypertrophy is not a problem. But a person who has the endurance genes and is looking to build bulky muscles may find it very tough and may not be able to get that good results out of those exercises because he lacks that genetic type basically.
What are the